Okay, so members, today we are going to see how do we handle permutations about circular arrangements. But please don't forget to subscribe to the channel. Now, start with, if I have, say, elements A, B, C, and D, if I want to arrange them in a circular way, of course I put A here, B, C here, and D here. But now, to arrange the three, you have to fix one, so that you can arrange the three. So, if I fix A as the starting point, now I can put B, C, and D. So always, if all the objects you have, you always fix one, such that you can use it as a reference point in arranging the remaining objects. So always, you note that if I have 4, I'll arrange now these ones, remaining 3, in 3 factorial ways. Meaning, when I have n objects, they can always be arranged in n minus 1 factorial way. Why are we reducing 1? Because one of those objects is what we use as a reference point to arrange others. So let us see an example there. In how many ways can 8 people sit on a round table? Now here said I have 8 people. Now, it means that now here, my n is 8. Meaning that the number of ways are going to be always, say they are n minus 1. So I'm going to be having 8 minus 1 factorial ways. And this one is going to give me 7 factorial, which will give me 40 ways. So always reduce the number of items by 1, then factorial ways. If you count this, in how many ways can letters A, B, C, D, and F be arranged on a circular table? That's part A. So I count my part A, I count them 1, 2, 3, 4, 5, 6. So my n is 6, meaning the number of ways are going to be, we say they are always n minus 1 factorial. So our n here is 6 minus 1 factorial, which is 5 factorial, and 5 factorial, you just press your answer, your calculator, and here you get 120 ways. When I come now to part B of this question, they are giving me now a restriction that if B and C are always together. So if B and C are always together, I write this as A, B, C, D, E, F. These are the letters I'm having. Now, these ones, for them, they are going to be together. Now, in counting, I count them as 1. So, I count 1, the order of these 2, 3, 4, 5. Meaning now my n this time is 5. So, now the number of ways I'm going to be now, we say n minus 1. So, 5 minus 1 factorial. But this A, this B and C, they can also be arranged in 2 factorial ways, because I can be having BC or CB. That's why I'm multiplying times 2 factorial, which is going to give me, this is 4 factorial times 2 factorial, which is going to give me 48 ways. Now, get the number of ways when B and C are not together. My part C, so the number of ways are going to be when B and C are not together. I'll get this one without restriction minus when they are together, because here they are together. Now, if I do that, I'll get the number of ways when they are not together, and that will be 72 ways. So remember, that's how we handle circular arrangements. When I come to this circular arrangements, by this time we are dealing with clockwise and anti-clockwise ways. Now, if I clockwise, we are going like this, anti-clockwise, we are going like this. If you have that case when we are arranging them clockwise and anti-clockwise way, now the number of, if we have n unlike objects, now the number of ways are n minus 1 factorial, then divide them by 2. Okay, question is there. How many ways can 1 red bead, 1 blue bead, and 2 white beads be arranged to make a necklace if a red and blue bead must be next to each other? So here, the number of ways are going to be, first of all, I have all of them are, I have 1 red, comma, 1 blue, and 2 white ones, meaning that their number is 4. So it means that my n here is 4. So my n is 4 because we are putting them in clockwise and anti-clockwise. Now I'm going to be adding 4 minus 1 factorial over 2. But times, of course, over to this 2 because we are dealing with clockwise and anti-clockwise. But now we have these 2 bits. The white ones are similar. So if they are similar, multiply by also 2 factorial. Then times, because the white and the blue are together, I mean the red one and the blue are together, it means that I can put them in 2 ways. So times 2 factorial ways there. So here I'm going to be having this as, this will give me 3 factorial times, this is going to give me this 2 will cancel over 2, which will give me, they are having 3 ways. 3 factorial is 6 divided by 2, you have 3 ways. So members, that's how we handle if you are considering the clockwise and anti-clockwise way. So please, members, that's all. Don't forget to subscribe to the channel. I wish you the best.